Hello everyone, in this video we are going to discuss structure for FIR filter or FIR systems. So first form of structure is called as direct form structure. We shall discuss direct form structure now. Basically the FIR system or FIR filter is of the form h of z is equal to 1 plus a m of 1 z power minus 1 plus a m of 2 z power minus 2 plus dot 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 plus a m of m z power minus m, where m is order of the filter, order of the system or filter. Okay, for example, say if it is a third order system, for m equal to 3 we have the system function h of z is 1 plus a3 of 1 z power minus 1 plus a3 of 2 z power minus 2 plus a3 of 3 z power minus 3. This is the transfer function of a third order FIR system. So where these a's are called as filter coefficients, okay, or the impulse response h of n. We can also call it as impulse response h of n. Okay, so we shall take one problem to realize a direct form structure of a given system. So for first problem, h of n is equal to say 1 comma 2 comma minus 0.5. okay, so I want to realize this in direct form structure. So solution for this is whatever may be the form of system they have given. Now here the system is in terms of impulse response, you have to convert it to difference equation form. Okay, so when I say difference equation form, it is nothing but combination of input and output. So y of n is equal to x of n plus some input am of 1 into x of n minus 1 plus am of 2 into x of n minus 2 plus dot dot dot. Okay, it is a combination of input and output in the left hand side and right hand side. So bring the given system in difference equation form and then you realize, so that it is easy for us to see what's happening in the realization. Okay, so to bring this impulse response to difference equation, first what we will do is we will convert this sequence into delta function. Okay, how do we convert this sequence into delta function? So h of n is equal to what? By default this is arrow mark is here, right? It's a causal system, arrow mark is at n equal to 0, this is at n equal to 0, right? Now this is corresponds to delta of n. This is added with delta of n shifted right one time, and its amplitude scaled by factor of 2, right? And this corresponds to delta of n shifted right 2 times and its amplitude is scaled by factor of minus 0.5. This is how we represent the given sequence in delta function, right? Now what we shall do is we shall take z transform, on both side. So what do we get? What is the z transform of h of n? It is h of z is equal to, what is the z transform of delta of n? It is 1 plus what is the transform of delta of n minus n naught is what? It is equal to z power minus n naught, and z transform of delta of n plus n naught is what? It is equal to z power of n naught. Okay, so because of time shift property of z transform, right? So 2 into what is this? Z power minus 1 minus 0.5 into what is this? Z power minus 2. Now so h of z is a system function and it is represented in terms of input and output is output z transform of output divided by z transform of input, that is nothing but y of z by x of z. So that is equal to the system function h of z, right? So I can write h of z as y of z divided by x of z, which is equal to 1 plus 2 z power minus 1 minus 0.5 z power minus 2. Now I'll take this x of z to the other side. What do I get? Y of z is equal to x of z plus 2 times z power minus 1 x of z plus minus 0.5 times z power minus 2 x of z. Now we shall take inverse z transform on both sides. So what is the inverse z transform of y of n? It is y of z, it is y of n is equal to inverse z transform of x of z is x of n. What is the inverse z transform of z power minus 1 x of z? So we have to use time shift property here. Z transform of x of n minus n naught is what? X of z, z transform of the sequence x of z times z power, how many times it is shifted? Minus n naught. Right? Similarly, z transform of x of n plus n naught is what? The z transform of the sequence times z power plus n naught. Okay. Now if I apply this property here, what do I get? So 2 into, this is nothing but, if that is the case, what inverse z transform? What is the inverse z transform of x of z into z power minus n naught? It is x of n minus n naught. So minus n naught is what? It is minus 1. So what do I get is x of n minus 1 minus 0.5. So what is this? X of n minus 2. Okay. Now this is in what form? This is in difference equation form. Difference equation form. Now we can make use of this equation to realize it in direct form structure. So we shall write the difference equation again here. So what do we have? Y of n is equal to x of n plus 2 times x of n minus 1 minus 0.5 times x of n minus 2. So now the structure is something like this. I have input feeding to the system, okay, and this is scaled by, what is the coefficient of x of n here? It is 1, right? It is scaled by 1, okay, and this input is fed to a simple system which is z power minus 1. Let me tell you what is this. So z power minus 1 is a simple system, okay, where if you feed input x of n to this system, the output from this system is x of n, sample of x of n is delayed by one sample. Okay, if you feed x of n minus 1, output will be x of n minus 2. Okay, whatever the sequence you feed, output from this system which is z power minus 1 is, its sample is delayed by 1. Okay, so what do we get here? So here I am feeding x of n, output is x of n minus 1, right? And what is the coefficient of x of n minus 1? It is 2, right? So what I'll do, I'll take a tab here and I multiply it by 2 and I'll add these two together. So what do I get across output of this? So it is 2 times x of n minus 1. It is added with what? 1 times x of n. Right? Now what I'll do, I'll feed this x of n minus 1 to one more delay element. So what do I get? Here output is x of n minus 2 because I'm feeding x of n minus 1. And what is the coefficient of x of n minus 2? It is minus 0.5. So I'll multiply minus 0.5 to x of n minus 2 and I'll add these two together. Okay, and what is this? This is nothing but minus 0.5 times x of n minus 2, and that is getting added with what? X of n plus 2 times x of n minus 1. And what is this? This is nothing but our output y of n. So this is direct form realization of FIR system. We shall take up one more example. Realize an FIR filter with impulse response h of n given by h of n is equal to 1 by 2 power n u of n minus u of n minus 4. This is the impulse response of the system. So, and I have to realize this using direct form structure. need to realize this using direct form structure. Okay, so solution. What is the first thing I need to do? I need to this is not in terms of sequence. I want to convert this into sequence. Okay, so how do I convert it to sequence? So what is this? This is actually multiplication of two sequence. One is 1 by 2 power n, and the other one is u of n minus 1, n minus 4. So what is this sequence? How does it this sequence looks like? So it is u of n. U of n is something like this. So 0, 1, 2, 3, 4, 5, 6, and it goes on till infinity, and amplitude is 1. What is this? This is u of n, and this is subtracted with what? U of n minus 4, right? And how does a u of n minus 4 looks like? U of n shifted right 4 times, right? So this is 0, 1, 2, 3, this is 4. So 1, 2, 3, 4. It is shifted 4 times, and this goes up to infinity, and amplitude is this. Amplitude is 1. So what is the resultant sequence? U of n minus 4. So 1 minus 0 is 1 at n equal to 0. 1 minus 0 is 1 at n equal to 1. 1 minus 0 is 1 at n equal to 2. 1 minus 0 is 1 at n equal to 3. But after 4, 1 minus 1, 1 minus 1, 1 minus 1, everywhere 0. So after 4 it is 0 everywhere, right? So all these amplitudes are 1. So what is this? N, and this is u of n minus u of n minus 4, right? Okay, and this u of n minus 4 is multiplied with what? 1 by 2 power n, right? So how does a 1 by 2 power n sequence looks like? So we are not going to concentrate on samples which are zeros, because anyhow 0 multiplied by any sample is 0. We are going to concentrate only on samples where 1 is there. So at n equal to 0, 1 by 2 power 0, and what is the value of 1 by 2 power 0? It is 1 at n equal to 0. At n equal to 1, 1 by 2 power 1, which is let me write a bigger one here. At n equal to 1, it is 1 by 2 power 1, which is 1 by 2. This is 1 by 2. At n equal to 2, it is 1 by 4. At n equal to 3, it is 1 by 8, right? And anyhow n equal to 4, 5, 0 multiplied by anything is 0, so we get 0. Now when I multiply this with this, what do I get? I get this sample itself, right? Because 1 into this is 1, 1 into 1 by 2 is 1 by 2, 1 into 1 by 4 is 1 by 4, 1 into 1 by 8 is 1 by 8, right? So therefore, so what is this? This combination of these two, I mean this 1 by 2 power n u of n minus u of n minus 4, right? And what is the resultant of this sequence? It is h of n is equal to, so at n equal to 0 it is 1, comma, at n equal to 1 it is 1 by 2, comma, at n equal to 2 it is 1 by 4, and at n equal to 3 it is 1 by 8. Okay, and by default sample at n equal to 0 is this, right? This is the one way to look at the signal. You can just you can do it in one more way. So let me show you. H of n is equal to what? 1 by 2 power n u of n minus u of n minus 4, right? You just have to give values for n. When n equal to 0, what do I get? H of 0 is equal to 1 by 2 power 0 into, what is the value of u of 0? U of 0 value is 1, minus, when equal to 0, what is the value of u of minus 4? So if this is minus 1, minus 2, minus 3, minus 4, so u of 0 minus 4 is u of minus 4, and what is the value of u of minus 4? Its sample is 0, right? So it is 0. So what do I get? 1 by 2 power 0 is 1, 1 into 1 is 1. When n equal to 1, h of 1 is equal to what? 1 by 2 power 1 into, what is the value of u of 1? U of 1 is 1, minus, what is the value of u of 1 minus 4 is 3, u of minus 3, right? 1 minus 4 is minus 3, so u of minus 3, it is 0, so which is equal to 1 by 2. Similarly, n equal to 2, h of 1 is equal to 1 by 2 into 1 by 2 power 2 into u of h of 2 is this, u of 2 is 1 minus u of 2 is 1 minus u of 2 minus 4 is u of minus 2, which is 0, which is equal to 1 by 4. And n equal to 3, h of 3 is equal to 1 by 2 power 3 into 1 minus 0, which is equal to 1 by 8. Okay, this is one more way to identify the sequence. Fine. So therefore I can write h of n I can write h of n in terms of delta function as, so what is this? This is delta of n, and what is this sample? Delta of n. Delta of n shifted right one time and its amplitude is scaled by a factor of 1 by 2, right? And it is added with, this is delta of n shifted right 2 time and its amplitude is scaled by a factor of 1 by 4, and this is delta of n minus 3 and its amplitude is scaled by a factor of 1 by 8. Okay, this is the sequence in terms of delta function. Now what I need to do, I have to take Z transform on both sides, right? So if I take Z transform on both sides, let me write it in the next sheet. So we have h of n is equal to what? Delta of n plus 1 by 2 times delta of n minus 1 plus 1 by 4 times delta of n minus 2 plus 1 by 8 times delta of n minus 3. So if I take Z transform on both sides, so what do we get? H of z is equal to Z transform of delta of n is 1 plus 1 by 2 times, what is the Z transform of delta of n minus 1? It is z power minus 1 plus 1 by 4 times Z transform of this is 1 by z power minus 2 plus 1 by 8 times z power minus 3, right? Now I can write this as Z transform of output, which is y of z, divided by Z transform of input, which is x of z, is equal to 1 plus 1 by 2 z power minus 1 plus 1 by 4 z power minus 2 plus 1 by 8 z power minus 3. I'll take this x of z to the other side. What do I get? Y of z is equal to x of z plus 1 by 2 z power minus 1 x of z plus 1 by 4 z power minus 2 x of z plus 1 by 8 z power minus 3 x of z. Now you take inverse Z transform on both sides. So what do we get? Inverse Z transform of y of z is y of n is equal to, this is x of n plus 1 by 2 times, this is x of n minus 1 plus 1 by 4 times, this is x of n minus 2 plus 1 by 8 times, this is x of n minus 3. So this is the difference equation we get. Now using this difference equation, I need to realize it. So let me write the difference equation again here. Y of n is equal to x of n plus 1 by 2 into x of n minus 1 plus 1 by 4 into x of n minus 2 plus 1 by 8 into x of n minus 3. So now direct form structure. So I have input coming, right? And this input is scaled by, what is the coefficient of x of n? It is 1. Now I feed this input to a delay element z power minus 1. Output from this is what? X of n minus 1. So what is the coefficient of x of n minus 1? It is 1 by 2. So what I'll do, I'll take a tab here and I multiply 1 by 2, right? Now I have to add these two. So what I'll do, I'll just take this here and I'll add it. So what do I get from the output from this adder? So it is x of n plus 1 by 2 times x of n minus 1, right? Now I'll add one more delay element z power minus 1 here. Output from this is what? X of n minus 2, right? Because I'm feeding x of n minus 1 as input. Now what is the coefficient of x of n minus 2? It is 1 by 4. So I'll take a tab here and I'll multiply it by 1 by 4. Now I add these two together. What is the output from this adder? So it is 1 by 4 times x of n minus 2 is added with what? X of n plus 1 by 2 times x of n minus 1. This is the output we are getting from this adder. Now one more delay. So this is x of n minus 3, and what is the coefficient of x of n minus 3? It is 1 by 8, and this has to be added with this adder. So ultimately what is y of n? Output y of n is what? It is this plus this, right? So it is x of n plus 1 by 2 x of n minus 1 plus 1 by 4 x of n minus 2 plus 1 by 8 x of n minus 3. This is the direct form realization of FIR structure. So basically, given a system, you have to convert it to direct form structure. After converting, so basically, given a system, you have to convert it to difference equation form. Once you get the difference equation form, it's easy to realize it in direct form. So next we shall discuss on second type of realization, which is called as linear phase realization. Now the linear phase realization, we are exploiting symmetry property of FIR structure, that is H of n is equal to uh, for example if n is odd, so 1 first sample will be equal to last sample, second sample will be equal to last but one sample, and third sample will be idle single sample, right? So it is n is odd, so H of n is 1 to 4 to 1. So we are making, if the impulse response obeys the symmetry property, then I can realize it in linear phase structure. Okay, now we shall try to realize this system H of n into linear phase form. Again, so we have to convert this sequence into difference equation form. First, before that, I have to convert it into delta function. So it is delta of n plus 2 times delta of n minus 1 plus 4 times delta of n minus 2 plus delta of n minus 3. Now I'll take z transform on both sides. So what do I get? H of z is equal to 1 plus 2 z power minus 1 plus 4 z power minus 2 plus z power minus 3. So h of z I can write it as y of z divided by x of z, which is equal to 1 plus 2 z power minus 1 plus 4 z power minus 2 plus z power minus 3. I'll take this y x of z to the other side. I end up with y of z is equal to x of z plus 2 z power minus 1 x of z plus 4 z power minus 2 x of z plus z power minus 3 x of z. Now I'll take inverse z transform on both sides. So what do I get? Y of n is equal to x of n plus 2 into this is x of n minus 1 plus 4 into this part is x of n minus 2 plus this is x of n minus 3. Now I'll do one more simplification here. So y of n is equal to, I'll just sort out the common terms. So I have one coefficient of x of n is 1, coefficient of x of n minus 3 is 1. So I'll just tag these two together, x of n plus x of n minus 3. Okay, plus I missed one term here. So h of n is 1, 2, 4. So this is 2 times plus delta of n minus 4, right? And this is 2 times plus z power minus 4. This is 2 plus z power minus 4. So this is 2 plus z power minus 4 into x of z, and this is 2 plus this is x of n minus 4. Correct, no? And now this 2 and this 2, I'll just tag it together. 2 times x of n minus 1 plus x of n minus 3. Now this 4 is alone, I'll write it as it is, 4 times x of n minus 2. Okay, so those are common, I'll just tag it together. That's what I did. I just grouped the common term. Okay, now we shall make use of this to realize it in linear phase structure. Okay, so let me write the difference equation once again. Y of n is equal to x of n plus x of n minus 3 plus 2 times x of n minus 1 plus x of n minus 3. What is this? This is x of n minus 4, right? This is x of n minus 4 plus 4 times x of n minus 2. I did a mistake here, so this has to be this and this are common, so this has to be x of n minus 4, and this is common, so this is correct. Fine, this should be 4. So realization, so I have x of n coming here, z power minus 1. This is x of n minus 1. Totally how many delay elements I have? N minus 4, so 4 delay elements. Z power minus 1, z power minus 1 and z power minus 1. So here it is x of n minus 2, here x of n minus 3 and here x of n minus 4. Now x of n and x of n minus 4 are tagged together. Let me tag it together. This is x of n, so this is x of n minus 4. So, and what is the coefficient of this tagged term? It is 1, right? So I'll multiply 1 here. So this is, what is the output from this? It is 1 times x of n plus x of n minus 4. Similarly, x of n minus 1 and x of n minus 3. X of n minus 1 is here. Let me take a tab. And x of n minus 3 is here. Let me take a tab. And I'll just add it both of together. And what is the coefficient? It is 2. So what is the output from here? It is 2 times x of n minus 1 plus x of n minus 3. Now x of n minus 2 is alone. So x of n minus 2 here. I'll take a tab and I'll just multiply here for this as 4, because I have 4 is the coefficient. Now what I'll do, I'll add these 3 together. And one more part is here. So this is the output y of n. Okay, so this is the linear phase realization of FIR structure. So we shall take up one more on the linear phase. So realize the linear phase FIR filter having the following impulse response. And the impulse response is h of n is equal to delta of n minus 1 by 4 delta of n minus 1 plus 1 by 2 delta of n minus 2 plus 1 by 2 delta of n minus 3 minus 1 by 4 delta of n minus 4 plus delta of n minus 5. Fine. So this is the impulse response and I need to realize it in linear phase structure. So solution. So what do we do next here? I have to take Z transform on both sides, right? So take Z transform on both sides. So what do we get? So it is h of z is equal to Z transform of delta of n is 1 minus 1 by 4. Z transform of delta of n minus 1 is z power minus 1 plus 1 by 2. Z transform of delta of n minus 2 is z power minus 2 plus 1 by 2 z power minus 3 minus 1 by 4 z power minus 4 plus z power minus 5. Now I can write h of z as y of z by x of z, which is equal to 1 minus 1 by 4 z power minus 1 plus 1 by 2 z power minus 2 plus 1 by 2 z power minus 3 minus 1 by 4 z power minus 4 plus z power minus 5. I'll take this x of z to the other side. I get y of z is equal to x of z minus 1 by 4 z power minus 1 x of z plus 1 by 2 z power minus 2 x of z plus 1 by 2 z power minus 2 minus 3 x of z minus 1 by 4 z power minus 4 x of z plus z power minus 5 x of z. Now I'll take inverse Z transform on both sides. So what do I get? Y of n is equal to x of n minus 1 by 4 times, this is x of n minus 1 plus 1 by 2 times, this term is x of n minus 2 plus 1 by 2 times, this is x of n minus 3 minus 1 by 4 times, this is x of n minus 4 plus this is x of n minus 5. Okay, now what do? We shall group it. Y of n is equal to this coefficient of this and this is common, so I'll group it together plus x of n minus 5, and coefficient of this and this is common, so what I'll do, minus of 1 by 4 into x of n minus 1, and this is plus x of n minus 4. So minus 1 by 4 into x of n minus 1, minus 1 by 4 into x of n minus 4, right? Now these two are common, so plus 1 by 2 times x of n minus 2 plus x of n minus 3. Okay, now we will use this difference equation to realize it in direct form, linear phase structure. So realization, so totally how many delay elements we have? Totally we have 5 delay elements, so we'll just write that 5 delay element first. So I have input coming here, and this is fed to 1, 2, 3, 4 and 5. Okay, so coefficient of x of n and x of n minus 5 is 1, so I'll group it together, this and this. Its coefficient is 1, and coefficient of x of n minus 1 and x of n minus 4 is minus 1 by 4. So this is x of n minus 1 and this is x of n minus 4. Let me write it. This is x of n minus 1, x of n minus 2, x of n minus 3, x of n minus 4 and x of n minus 5. So I'll group these two together, and its coefficient is minus 1 by 4, right? And coefficient of x of n minus 2 and x of n minus 3 is 1 by 2. So x of n minus 2 is here, and x of n minus 3 is here. I'll take a tab, and its coefficient is 1 by 2. Now I'll add these three together. This is our output y of n. Okay, this is the linear phase realization of FIR structure.